we're going over this homework problem, which is
Okay.
3A number 4. We try to find the length of the curve. We're given this vector function right here. So let's first review the formula for the arc length of the curve. Okay, so what is the formula? The arc length, let's call that L, is equal to integral of, well, there are different ways to write the formula. One way to write the formula over here is you can have this. Think about this is the first function. Okay, so this is the
Oh, the
x
derivative
component,
of each
the y,
component.
and this is the z, right? So that will be dx dt square plus what? dy
dy dt
square
dz
dt
dt.
square, right? And then dt, and then t go from, well, it is already given right here. It go from 0 to what?
Pi
0 to power 4, right?
pi 4.
So we got the formula right. Now we just need to get the ingredients ready, okay? So
Okay.
now we're going to get dx dt, okay? So let's think about what's dx dt. So we have x equal to this. What's dx dt?
It would be negative 4 sine of 40.
You got it. Good job. Okay. Okay, so what's dy dt?
4 cosine 40.
Good job. And dz dt?
Okay, this one's hard. I think it's
It is, okay, let's
4.
do step by step. Okay, so 4 is a constant multiple, so bring it out. And then the derivative of ln, okay, this, we have to use a chain rule. So the ln is the outer function. So derivative ln is 1 over whatever inside here. So we'll have 1 over whatever inside. The inside over here, okay. So yeah, so the inside over here, it is cosine of t. So it's 1 over cosine of t. But then by the chain rule, we had to multiply by the derivative of this inner function, which is cosine of t. Now, what's the derivative of cosine t?
Negative sine t.
You got it, negative sine t. So you just use the chain rule to get the derivative right here. So you got it right. Okay, good job.
Okay.
All right, now all we have to do is put this ingredient, all of this, into this formula over here. Okay, now let's do that.
Okay.
We have the arc length is equal to the integral. Okay, then the last one, okay, well, this one over here, we could simplify this a little bit. Do you remember sine over cosine is what trig function?
Was it tangent?
Yes, that's tangent.
Okay.
So sine over cosine is tangent. So this is going to be 4 times, actually negative 4 tangent of t. Okay.
Okay.
All right. So that will be plus negative 4 tangent of t and then square. And then dt, t go from 0 to pi over 4. Let's see, what do we have over here? So let's think about this 2 first. Now this one over here, it is 16 sine square of 40, right?
Okay.
It is 16 cosine square of 40. Now if we take the 16 out, then we'll have 16 times the square of sine 40, and then cosine square for t. And does it ring a bell about the trig identity? What is it?
It'll be equal to 1?
Yes, that's equal to 1. Okay, good. All right, now let's get to the second part over here. It is, this part over here is 16 tangent square t, right? Okay, now the thing here is, okay, let me write the next one. Okay, so this will be 0 to power of 4 square root of, now how about we're going to take the 16, okay, we're going to take out this 16, this common factor 16, so I have the 16 over here, and then we're going to have this in the parenthesis. After take out 16, we have 1, so we put 1 there, and then plus, after take out this 16, we have tangent square, so we put tangent square. Okay, now, so there's another trig identity that you probably want to remember also, okay? So that was the 1 plus tangent square is equal to secant square. Okay, so let me write down the trig identity over here. So we have sine, remember sine square of alpha plus cosine square alpha equal to 1. That's one important trig identity. Another one is actually secant square alpha equal to 1 plus tangent square alpha. So this two is actually two common trig identity that it's better that we can remember this. So now, what does this become?
Secant squared?
Yes, you got it. Okay. So that become secant square of alpha. Oh, not alpha, t. Okay. Oh, don't forget, I forgot to put the dt at the end. So let me put this one. So that's dt outside here.
Okay.
All right, now let's finish this. Let's think about what we have. So we have square root of 16, it is what?
4.
4, yes, so we have 4. And now square root of secant square is?
Just secant?
Secant, yes, that's secant. Now we're supposed to put the absolute value for this because square root, this is a positive square root. So positive square root of a square, the result should be positive. So to ensure it's positive, we need the absolute value over here. So, and then put dt. Now, in this case, the absolute value is actually, it doesn't make a difference because when t go from 0 to power of 4, secant will be always positive. So in this case, this will be always positive. Then in this case, you can remove it. Okay, so the next step over here, that should be equal to this. So we know secant t is always positive when t between 0 and power of 4. So we can remove the absolute value. Okay, now all we have to do is, that is the, in Math 110b, okay, we actually remember this antideuty of secant. And it turned out that, okay, let me give you the formula. Antideuty of secant is, well, secant and tangent always go together. So it's secant t plus tangent t. However, it is the ln of it. Ln of the absolute value of the sum of these two plus c. So this is a formula for antideuty of secant of t. So we have 4, and then we're going to have ln of the absolute value of secant t plus tangent t, and then t go from 0 to power of 4. Now all we have to do is just substitute and evaluate. Okay, let's just do that. Okay, so we have 4, and then now let's leave the 4 outside. Okay, so we have ln secant of, let me just write down. Okay,
Mhm.
secant of power 4 plus tangent of power 4, and I'm subtracting ln of secant of 0 plus tangent of 0. Okay, now all you have to do is just remember the value, the trig value. Secant of power 4 is, what's secant of power 4?
Oh God. um,
It is square root 2.
oh,
Okay, I'll give it to you. Okay, tangent of
okay.
power 4 is 1. Secant
Mhm.
of 0 is 1. Tangent of 0 is 0. So therefore, this one here is equal to 4 ln of square root of 2 plus 1. Okay, it is positive,
Mhm.
so I don't need the absolute value. Now, this part over here, we get ln of 1. And what's ln of 1? ln of 1
Uh,
is equal to 0 because remember this is the base e, right?
mhm.
So the base over here is e. So e raised to the 0 power equal to 1. So this
Uh,
base over here raised to this exponent, you get back to 1. So
mm,
ln of 1 is equal to 0. So this part over here will be equal to 0. So we have only this part here left. And that will be the final answer over here. I think this problem was a little bit harder because it requires you remember the formula for antiderivative of secant.
yeah.
Also, you need to remember these two trig identity.
Mhm.
Uh, now, this formula here we already talked about in class, so maybe
Mhm.
it's still fresh in your mind. But yeah, but you did it.